Hi everyone, welcome back to another video on my channel. Today I'm going to talk about Raspberry Pi Pico W or WH. And the reason I'm talking about this one is that I'm going to start a series of videos on this and basically utilize this Raspberry Pi board or component basically to do a bunch of robotics stuff. So the end of this series, at the end of this series, we would be able to use the Raspberry Pi Pico to design a robot that can follow a line and do simple, basically line following, and that would be it. But before doing that, we are going to just learn a little bit about how it works and then do other simple stuff with it first and then move on to that one. Okay, so a little bit about Raspberry Pi Pico WWH is that W and WH version pin-to-pin layout or pinout are exactly the same. The only difference between them is that WH comes with these pre-soldered pin headers, so you can directly use them on a breadboard, right? So that's the only difference. Nothing else is different between them. And more about these. So both of them have the same functionality, the same pinout, and basically now what is Raspberry Pi Pico WWH is that it's a 32-bit IoT capable board. It has RP2040 dual core Cortex MCU. Sorry, this is the one. So this is the microcontroller in it, and it has, this is a 2 megabyte basically flash memory, and then this is the serial port or USB port where you can use it for both programming and then also powering it up. So let's just say this is a very brief review about this board. It's kind of like a computer or mini microcontroller. You can use it for robotics, right? I'm gonna assume you know what you can do with this, right? So in this video, I'm going to set up a board where we can basically blink an LED with this. So as you know, or you probably know, on a computer, to do anything, like imagine this as a computer, right? You need the hardware and then you need the software, right? So we're gonna start with the hardware and like setting up the board, and then basically uploading a sketch to the Raspberry Pi, and then running that, compiling that, and running that to be able to blink the LED. Okay, so first the hardware. Let's set that up, and then after that we can try to talk about the programming as well. Okay, so if I want to set up the whole board in one video, it's going to be a very long one, so I try to divide it. Okay, I'm going to try to talk about the pinout first. Okay, so I hope I was able to put up a Pico W pinout on the video so you can see it. But basically we have about 40 pins starting from one here. If you can see, you see like it says 1 and then 2 to 40, right? And if you look at the pinout, all of these come, some of them are the ground signal, some of them are the VCC or 3.3 volt, and then some of them are for basically input output and stuff like that, right? So again, we are assuming you know this, and we are just gonna set up a board. So hopefully that would help you to see if you have a circuit with a Raspberry Pi, how you can read the pinout, how you can read the schematic to set up that board. Okay, so now that we know the pinout, try to keep the pinout on like close when you're doing this. So try to print it out, Google it. Like if you Google Pico W pinout, you should be able to see it. So put it on a second monitor, or as I said, print it so you can have basically look at it all time when you set up the circuit. Okay, now we are trying to put this circuit basically. Okay, so first thing first, okay, even if you look at the schematic, it's not going to tell you otherwise, but out of these 4 pins, about 4 pins on this side, and then I think 4 pins on this side are the ground signal, okay? So that's very easy, and then you can, whenever you have a schematic that has a Raspberry Pi, basically, or like a circuit board like this, you can always just start with like connecting the pins that you know to like source signals or ground signals. That would make your life much easier, okay? Before going through that, let me just quickly explain the breadboard. The description of the breadboard is on one of my older videos, but remember that on a breadboard you have these 2 sections. Let's look at them here. 2 sections of, this is one side, this is one side, and then each row here is connected together. So if you put a component from here to here, you're basically short-circuiting it, right? And this side the same thing, but these 2 sides are not connected together. Then on these columns, as it says minus for all of them, these are all connected together, connected together, right? So these are very good columns to basically use them, as it shows plus and minus basically as your different input voltages, right? Like for example, in a lot of circuit boards you have a VCC or VDD or like some other voltage. Like you can have different, like 5.5 5 volt or 3.3 volt. So you can like assign one of them to these columns and then assign the other one to this one, and then the blue one can be your ground basically. Okay, so that's why I put the Raspberry Pi like this, because I didn't want to put any of these short circuit any of these pins together. If you put it that way, then basically you would short circuit a lot of pins together, right? And it wouldn't fit all of the pins. So the only natural orientation for this Raspberry Pi to go on the board is this one, okay? So I hope I'm clear about why I put the board on the breadboard like this. Okay, now so next, let's do that. Let's basically find the pins that are grounded on the Raspberry Pi, and then basically connect those ones to the ground. I'm gonna assign the blue ones as my ground on the 2 sides, and that's perfect because I have basically a ground line that is close to these pins, and then a ground line that is close to these pins. So I don't need to go from here to here, right? So let me just show you how I'm going to do that. Okay, so first thing, it says pin 38. Or actually, why did I start from the end? Let's start from pin number 3. If you look at the Raspberry Pi Pico pinout, it shows you that pin 3 is basically grounded. Okay, perfect. So you have to look at my chunky fingers, but let's look at that. So pin number 3, that's this one. I started exactly at the beginning of the board, so that's a lot easier for me. So 1 is here, 2 is here, 3 is here, and it doesn't matter which one you choose. Again, these are all connected on this side. So pin 3, any of these can be connected to this line that is going to be my assigned ground, and then that would work. So pin number 3, that's the first pin. We're going by order. That's going to be grounded, right? Okay, then we have pin number 8, that's also grounded. And I got a bunch of these little wires. You can buy them too, they come in different lengths, so that those are perfect actually. Okay, then pin number 8 I said, right? So 5, 6, 7, 8. Okay, that one, it's gonna be a little bit trickier. You have to bend it like this, but that works too. Then we have pin number 13. So bear with me. 11, 12, 13. Okay, then we have pin number 18. That's also grounded. 18, it's easier to go from this side, so that's gonna be, so again, perfect. Then on the other side we have 38, so this is 40, 39, as you can see 39, and then this is 38. I hope this one, yeah, I think I used this one before, so 38 is going to be here. I push it down, perfect, right? And then after that we have pin number 33, 33, and then 23 as well. 23 is this one, this is 21, 22, 23 is this one. I'm trying to go with the easiest one first, okay, and then 33 or 20, 33 and 28. So this is 23, 24, 25, 26, 27, 28. And one last yellow one, and then we are done. Did I calculate that right? 21, 22, 23, 24, 25, 26, 27, 28. Okay. I'm setting this up for the first time, so like I might be slower than what you would see. 28, 29, 30, 31, 32, 33. Okay, so this is our last grounded one. Okay, so these are the grounded ones. Okay, these are regardless of the schematic. The pinout says you have to ground these pins. Oh, I had it here. Okay, it's fine. Okay, now let's go back to the schematic. Okay, the schematic, as you can see, or I'm hoping I can put it on the video, is that on the schematic the pin numbers that you see there are on the schematic is not related to the physical structure, right? Like for example, you see pin number 36 on the from the top on the right side, it's being the third one, right? Whereas in the pinout, if you look at pin number 36 or 3V3 out, it's gonna be like 5 from the top. So be careful. That's why I said like have the pinout in front of you at all times so you can see that, right? So I'm gonna start from the right side of the Raspberry Pi, and then basically from the schematic see what we are going to do, right? On the schematic it says V bus or 4D is not connected to anything, right? Okay, so we leave it open. Then it says VSys is, or pin number 39 is connected to a diode. Okay, that's fine. Let's do that. So what we are going to do is pin number 39 is here, and if you look at the schematic, remember the orientation of basically a diode is that this line matches the line from the bottom of on the bottom of the triangle, right? So be careful to do that. So right now it says this line has to be toward the pin 39. So this is the way I'm going to put it, because in the schematic this line is facing pin number 39. So that's pin number 39 here. You see, this is a bit too short. So what I can do is try to use a wire, connect this wire to pin number 39, and basically transfer this pin and all of this connected other pins to it to another location. Now basically all of this row is the same as all of 39, is equivalent to that. So I'm going to treat this point as pin number 39, right? So then what I can do is, again, this has to be toward 39, so you can put it that way. And then on the other side, we have D2 connected to VPAC. Okay, If you look at the schematic now, we have two input sources. We have VPAC and then 3.3 volt. So by choice, it's up to you. Yeah, I'm gonna choose this one, this plus as 3.3 volt, and this plus line as VPAC. So all I'm gonna do now is basically bring this one here, and that way connect it to this guy, right? That would be my VPAC. So again, I'm choosing this line, all of this plus line as VPAC, and this one as 3.3 volt, right? And it says on the, I think this is the anode side of the diode, if I'm not mistaken, and then connect the anode side as the schematic shows to VPAC. Okay, so I'm gonna put, it's gonna be messy, so just ignore that. I know some people do circuits very nicely, but I try to get it done and then see how it looks first before try to tidy it up and start cutting like extra wires and stuff like that, because still we don't know that if this is gonna work here, right? Okay, but for now, based on the schematic, if this is VPAC line, then we're good. Then it says pin number 36, it says connect that to 3.3 volt. Pin number 36 or 3.3 V3 underscore out, that's basically pin number 36. So we were at 39 here, and then this is 38, 37, 36, exactly line, the fifth line. And we said this plus is going to be our 3.3 volt. Okay, so let's do that. Let's connect this line to 3.3 volt. Perfect, right? Okay, we're good? Yes. Okay, 35 is free. Then the next pin that we have is, it says 19 or GP14. Okay, again, don't be misled by the order of the pins on the schematic. We have to go find GP14 or pin 19 on the pinout. GP14 or 19. That pin is actually right here. It's number 19 here. So we have 20 pins here, 20 pins here. Starts from 1, goes to 40. Pin number 19 is right here. So it says pin number 19 has to be connected to, I forgot where were we. Okay, so if you follow pin number 19, it goes to R2, which is a 1 kilo ohm resistor. Okay, so pin number 19 is going to a 1 kilo ohm resistor, and then after that to the red LED, and then to the ground. Okay, so pin number 19 is going to go, I'm gonna move it just to here, to a resistor, right? That's the pin, and then bring it here. I'm gonna cut these extra wires later, right? So for now, don't worry about the messiness of it. Let's just see if we can find the space to basically connect all the pins to where we want. Then after the resistor, it's the diode. And remember, the diode symbol, the LED symbol is a triangle with two arrows coming out of it, right? To show the emission. Now this is the LED. The shorter side, I hope you can see it. The shorter side is the one that where the line at the bottom of the triangle is, and this is the head of the triangle, basically the side of the triangle. This is like the pointy side of the triangle, right? So based on that, after the resistor, we're gonna put the positive side here, and then after that we have the ground, so we can just easily go directly to here. So again, so pin number 19 is going to the resistor, and then the resistor gets connected to the the anode side of the LED, and then the cathode goes to the ground. And this line, remember, all of it is the ground. So if I can show you, it's the ground here. So this is the LED side, right? Then after that, we have pin number 20. Okay, pin number 20 looks very complicated. We can work on that after that. So let's leave 20 for now, because I have to figure out a way. Okay, while I was looking that, you see this is a very common mistake. See, I was looking from the top, I didn't see that the diode wasn't actually going to the resistor. So either you can move the diode pin or the LED pin or the resistor to put them in the same row. Where I had them, I had one of them here, one of them here, so be careful. Okay, I skipped pin number 20 because it looked kind of a lot. So for now, I'm gonna go to the next one, GP28, and then that's a potentiometer, right? So whenever you see a resistor with an arrow coming toward it, that's a potentiometer, right? And it says, so right now I have this one, right? I have this potentiometer, right? It says basically one side of this guy is going to 3.3 volt, and then the other side of it is going to the ground. That's fine. And the middle one, which is the variable, the variable resistor is going to pin number 34. Ooh, where is 34? So pin number 34, this is 40, 39, 38, 37, 36, 35, 34. Okay, so this one, so we have to find a way to connect this side to the third, basically third leg of the potentiometer, right? So the only way to do that is just to try to bring that pin out to here somewhere, and then do that. Okay, to do that, let's pick pin number 34 or GP28. So again, 36, 35, 34. Here, it's gonna be messy, right? Later, what I'm gonna do when I'm cleaning up this board is that I'm gonna try to move this one under the Raspberry Pi. So let me see if I can move out, zoom out, and then, so let's say, so this is going to be our pin number 34 right now. Then easily, what we need to do is, again, the middle of the potentiometer has to go to here, and so here, and then the other two ones have to be in two different rows. Remember, this is a very key part. They have to go to different rows, otherwise you short circuit them. So what we can do is get creative, and then do this. Okay, I tried to push this in. I hope that it worked. So if you look at it here, you need to make sure that the third leg or the middle leg that is here is basically connected to this row. So that's critical. And then these two lines, we're trying to get them. In the schematic, it says the one side is going to the 3.3 volt, which is this line. If you zoom out, remember that we assigned this side as 3.3 volt, and then this side as the ground. Okay, so now that's what we're gonna do. It really, in the potentiometer, it doesn't matter which side you're picking as your 25K. Actually, this one it says, but you can, it says 25 is here, 0 is here. I think at least that's what I think. But it doesn't matter. If you rotate it completely, then it should be you should get like 25K or 0 on either side. So the 25K, I don't know, I'm going to connect one of them to the ground and then the other one. So let's first do this one first. This one is going to go to the 3.3 and then we connect this back on. Okay, so something like this. Okay, maybe you can do it better, but for now I'm trying to just show what's going on here. Okay, now all is left is our pin number 20 and then pin number 30. Okay, as you can see, they're quite similar. What we're gonna do is a user switch and MCU reset. The reason we do this is actually like these two switches are so that like whenever we want to put the board in the programming mode or something, like if we want to switch modes, we don't have to keep disconnecting the USB cable. Okay, so we're gonna put the user switch and the MCU reset there to be able to do that. Okay, now let's just start with one of them and then the other one is similar. It's the same thing basically. So pin number 20 is going to be here, right here, right? So first we need to bring out this pin number 20 because it's very very crowded there. So what we're gonna do is pin number 20 is exactly the last one on the left side. We're gonna bring it out to here, let's say. Okay, and then here it says connect a capacitor, right? The capacitor to there and the ground. Okay, so easy. That's easy. It's gonna go from there to the ground. Perfect. Again, you can tidy this up by cutting all of these extra legs. I've never seen anybody needing this much leg on a connector, but okay. Okay, so that's one. Be careful again to make sure that these are in the same row. You don't know how many times that happens. Okay, then we have a switch. Okay, this is called a switch, right? The switch has a weird symbol. It shows pin number 1 and 2 are going to the ground and they're connected together, and pin number 3 and 4 on this 4-pin or 4-legged connector are connected together and they're going to a resistor and then they're going to a 3.3 volt. Okay, so first let's see if we have to connect those legs together or they're connected by default. It's an inner thing basically. So first let's find pin number 1 and 2. So maybe if I turn it, it would be easier. Okay, you see it? I'm using a multimeter and I put it on a diode. You see this one, diode thingy? And then as soon as I touch them together, you hear that? Oops. So if something is short-circuited, I should hear that. So whenever you want to check continuity on a circuit, that's a very useful basically feature on a multimeter to use basically. So okay, so let's see pin 1 and 2. Ooh, it's gonna be tricky. I only have 2 hands. Okay, so I have a feeling we already got them. Okay, so these guys, it's hard. I don't know how to keep them. These guys are connected together. Okay, so this guy is basically connected to this one and that one is connected to the other one. Okay, so pin 1 and 2 are these two because they're connected together, and 3 and 4 are these ones. Okay, or vice versa, it doesn't matter. Okay, so now if you put these guys like this, I think we got it. So we need to bring The capacitor side, the capacitor and then pin, if you look at the schematic, it says pin number 20 has to be connected to pin 3 and 4, which are connected together. So these two guys, let's say these are like 3 and 4, and they are both connected together, and they're going exactly in the same row as pin 20 and the capacitor. So this is very important when you're making parallel stuff, or like parallel stuff, or basically series of stuff. Be careful about these things. Okay, so I'm gonna put them this way and then explain why this is okay. Okay, so remember that we had these two pins connected together, right? As long as I make sure nothing comes here, I'm okay, because now I got these three in the same line, and this is connected to this guy, and then basically I can bring 3 and 4 to the resistor, and then after that to the 3.3 volt. Okay, I could have rotated it the other way. I couldn't rotate it the other way because it wouldn't fit. Okay, so all I need right now is a 10K capacitor. This is a 10K capacitor. Zoom. Okay, 10K capacitor. Is it? Okay, I can't really see. So again, you can use, I can't see color. So you can use the multimeter. Oh, this is actually 1K. Let's see. Is it 1K or 10K? This is 1K. So we need a 10K. Okay, perfect. I found my 10K capacitor. Okay, so remember this is 3 and 4. This we decided that this is our pin 3 and 4. You could have chose the other way around, doesn't matter. And then this pin is connected to that one. This pin is connected to this one internally by the switch design, and then we are connecting all of these 4 things together to the capacitor, and then at the bottom of the capacitor is going to 3.3 volt. Perfect, right? Not super perfect because like we have stuff jumping from on top of each other, but that's fine, right? Okay, then pin 1 and 2, again these two are connected to each other, so if you ground one of them, the other one is going to be grounded, again by design. We definitely need to tidy this wire circuit, but for now accept it for what it is, messy. Okay, so now we're gonna go and then do this one. It's too long, we need something shorter. Is this one shorter? No, it's not shorter. I think it's one of the blue ones. Okay, hopefully this would work. So now we are connecting pin 1 and 2. Pin 1 and 2. This is connected to here by design, and then we're connecting both of them to the ground. You could have done the other one as well. It doesn't matter, right? It's just that I prefer to jump from one wire instead of 2. Okay, last one. Last pin that we need to do something for it. Pin number 30. Okay, so pin number 30 again is very similar to this one, but we're gonna do it anyway because we need reviews always to remember things, right? Pin number 30 is, doesn't matter which way you count, but this is 21, right? 21, 22, 23, 24, 25, 26, 27, 28, 29, and then 30. This is pin number 30. Ooh, how are we gonna bring that here? Okay, and one. So what we can do here is use another wire. Again, a lot of these would be easier next time because we know what we are dealing with. So what you can do is transfer a lot of these pins transfers underneath the Raspberry Pi. right? So this is too short. I'm going to use the green one. Okay, I decided to bring pin number 30 to here for now. Okay, and then pin number 30, similar to that, it goes to a capacitor and then goes to the switch, and the switch goes to the 3.3 volt. Okay, so first the capacitor. This is the capacitor. Okay, so I chose row number, I don't know, 22 to do this. So I want to be careful that I put the capacitor 22, and then again that goes to the ground. So you can rotate it, bring it here, and then 22. Perfect, right? Okay, then after that we have the switch again, another switch. So for the other switch, what we can do is try to move things a little bit, and then maybe that's too big, bring it a couple of rows aside just to have more space. Basically, that's all we're gonna do. This is too big as well. Just maybe one row, 2 rows. As I said 1 row and then moved 3 rows. Okay, so again this is still row number 22, and I moved it to row number 25. Okay, and then again I'm gonna put the switch, and then we know that the sides are connected together. So if we put it here, you see, like, this is a very bad one, because if I move it here, then I'm gonna overlap with this row, and I shouldn't do that, right? So we have a very tight space here, so I'm gonna move it one more here, and then try to use a smaller wire to transfer this. You can just not do that, you can just try to fit the switch right there at row number 22. I'm just trying to show you like different methods you can expand your space. Okay, I use a smaller wire to move row number 22 to row number 24, and still you see this guy is connected to 22. And then also we have no overlap here, no overlap here. And again, if you use the multimeter, you can see that these are connected together, although these two sections are completely separate. This is because of the internal design of the switch. So we're going to treat these guys as these two pins as pin number 3 and 4, because we connected them exactly to the point where the capacitor is, right? And then these ones as pin number 1 and 2, and they're going to go to the ground. Pin number 1 and 2 are connected together and they go to the ground. So, and that row is row number 26. So all we need to do is connect row number 26 to the ground. We are going to the ground. Okay, so pin number 1 and 2, these two are going to the ground. And then pin number 3 and 4, we need to connect them to 10K, and then move that to basically this one has to go to a 10K, and that 10K goes to the 3.3 volt. So that's our 10K, and then this is our 3.3 volt. Let's see, do you see that? 3.3 volt, right? Exactly, because the resistor, the pin 3 and 4 of the switch, the capacitor, and then pin number 30 of the Raspberry Pi, they all have to be in the same row. If they're not in the same row, you have to have the wire that connects them to the same row. That will show like all of those are the same point on the circuit, basically. So that's it. This is the hardware. This is the hardware, and no, I'm missing something. Yes, you see in the middle of the board we have a 1K. Look at R7 3.3 volt, and then it says D3. That's another LED. So that one is easy. That's not connected to our Raspberry Pi, so we're gonna use that one. We're gonna set that up basically. So that's 3.3 volt going to a capacitor, to a resistor 1K. This is 1K, and then after that we're going to a green LED. This is our green LED. Okay, it's very bent. I'm reusing it from another circuit. So first let's just straighten them to find which is the positive side, right? This is one way to do it, right? Let's say you cut the LED. How do you want to figure out? Again, multimeter, diode. Use the diode to find out one of them if you're in the right direction. Actually, let me show you. So I'm in the diode side of this, right? And then if I connect the black one to the longer leg, let's say I don't know it's a longer leg, right? I'm just trying to find out the polarization, right? Nothing happens. I know it's out of zoom, but I hope you see it. Now let's go, I do it the other way. You see it turned. This is showing that positive one is this one, basically. So again, if you have an LED, you don't know if it's working or not. You have an LED, you don't know the polarization, which one is positive, which one is negative. You can try to basically use your multimeter. And you saw that this is not a fancy multimeter. Most of them have this feature, like all of them basically, to detect an LED. Okay, easy. 3.3 volt. You see, 3.3 volt resistor. Then the resistor and the LED having the same row. They're in the same row. And then that one, the LED goes to the ground. Okay. The green LED, that's the one we're gonna start blinking in the next video after we go through. Okay, so yeah, this is the whole thing. It's very messy, I know it. We're gonna try to clean this up, and then hopefully in the next video I'll just use the clean version. You can try it if you have these guys. They are kind of cheap, so you can try it as well. Go through the videos with me, and then at the end let's see if you can have a robot that follows a line.